Thank you.
Okay, great. Hello, everyone, to all of you who have tuned in. If you would, please go to this YouTube link that I've pasted into the chat box a couple of times, but just most recently, just so everybody has it. And go to that video there. What happens when I do that? Let me just make sure that we're all doing the right thing. Okay, pause it. I'm sorry, this is not quite what I intended to do. And then return it to where the title screen is. It's for me, it was -134, but there's a title screen that says a parameter reduction window into computational science and engineering. And again, I'm sorry, this is such a pain. But if you see that, please let me know once you get there. This was supposed to be a thing where we were all going to watch it together. Turned out to not work. All right, I see that Jeffrey and Mohit are there. If I could see a couple of thumbs up just from your screens. Rajshri. Okay. Couple, yeps. Okay. I'm going to go ahead and start. So what I want to do is start from this point. We're going to watch a little bit of this video, which was part of my colloquium talk. The point is to give you some kind of information about my my research and working with me. So we're going to start by watching this for probably 2 or 3 minutes, which is just the introduction. Then I'm going to come back and I've got some slides and I'll go through those slides. The slides are mostly about working with me as opposed to what my research is. And I think you'll get that sense as I start going through them. And then afterwards, that should only take about 15 minutes. Afterwards, it's pretty open. We can go back to watching, well, it's weird to go back to watching the colloquium talk that I already gave, but it is the best representation of my research. Yeah, so we can go back and watch. I mean, we can watch it together if you want, but otherwise I'll just say, go watch it and then ask me questions later. And this sounds really dismissive and I didn't mean to be that, sorry. Okay, let's watch this video just for the first couple minutes on 1, 2, oh, sorry, I'll count down from 3. 3, 2, 1, go. If you get to the screen that says models with many parameters, please pause and give me a thumbs up. My last comment was, when you get to the point of models with many parameters on the screen, please pause. All right, I see a few there's and a few paused. So let me go ahead and go back to my slides. So as you saw, this is a bit about computational science and engineering, and then a bit about working with Paul. So that first bit was just meant as a very general conceptual introduction to what computational science and engineering is, what it can do. And it's the sort of the very broad umbrella of where my work is. Okay, and actually for this part, I have kind of scripted, I've scripted what I'm going to say, or kind of semi-scripted it. So this will be a little bit, this will feel a little bit like a teleprompter. But that's okay. We're cool teleprompters. All right, so computational science is very broad, and we'll see more about my work in a minute. But before that, let's shift gears to how I'm planning to work with PhD students. I'm trying a different model. Instead of, let's see, does this work like that? Okay. Instead of trying to work with PhD students, fund PhD students with external grants, I want to help each student find their own funding, like a fellowship. And so I'll tell you this now and then repeat it at the end too, that if you're interested and you think you might be eligible for an external fellowship and you want to talk about it with me, send me an email with your CV and a statement about your interests and your passions, and then I'll email back in a day or two. And so if I don't think that we'd be a good fit, then I'll let you know. And if I do, I'll request to meet and chat with you. In all, I hope to advise about 4 or 5 applications this time around. Okay, so you want to get a fellowship. Well, here's what we'll do. We'll identify fellowships where you're most competitive. We'll collect application deadlines and requirements. We'll take ideas from a brainstorm to a plan. Then we'll carefully prepare the review materials. Prepare and review the materials, and then we'll submit and cross our fingers. I don't have a template for this. I've advised a few successful fellowships, and I have a bag of tricks, but the applications will depend on many factors, and most of all, you. So I offer no guarantees, but I want to help you put together your strongest application possible. So the odds of any person getting the fellowship are not great. I'm still putting together the statistics, but it's a challenge. So here's a bit of some straight talk. So no matter how exciting the idea is, if you don't get the fellowship or find other funding, then I won't commit to be your advisor. However, I will work with you to find other opportunities while the applications are processing. And so if you find yourself with both a fellowship and other opportunities, then you have a choice, and that's a very good position to be in. Okay. I want to talk a little bit about diversity and inclusion in the context of these awards, the fellowship awards. So at the university, we talk a lot about diversity and inclusion, and we're always working toward increasing representation and creating a more welcoming campus. I share these values, and I think a lot about my responsibility. And I think about how these values we seek to promote, should impact who has access to these prestigious fellowships. So let me talk about a subject that's a little bit taboo, and that is the applicant's identity. So it's not unreasonable to conclude that applicants from underrepresented backgrounds are given closer examination, greater benefit of the doubt, and more advantage in the award selection. Now, this is a somewhat dangerous conclusion. A fellowship recipient may feel uncomfortable believing they received the award or even advantage because of identity as opposed to merit. And these kinds of beliefs can promote imposter syndrome and general reluctance to take risks. And I hear that, but let me offer also let me offer an additional perspective. We're in an interesting moment. Some type of explicit social advantage adjustment seems necessary, certainly in my opinion and many others' opinions. But our laws struggle with explicit favoritism, like in the case of affirmative action. The compromise has not been entirely satisfying. We collectively accept the responsibility to promote underrepresented candidates, but doing so without care risks both violating equal opportunity laws and invalidating the candidate. But here's my suggestion. Let's recognize the moment and participate. If you come from an underrepresented background, you may receive some preference. This is a good thing. This is the right thing towards social progress. Previous generations were kept from these opportunities, so I encourage you to take the advantage and apply. So here's how I can help. So I want you to imagine a project so interesting that it assuages any fears and you own the project. So we'll counter any social fears you might have of like not belonging with technical imagination and excitement to solve a problem. If you're worried about imposter syndrome, I can help you find the confidence in your work. And I can talk to you about managing risks as we put together a competitive application. So you'll apply with your ideas and your accomplishments and not your identity. So let's say you get a fellowship. Well, congratulations. You now have the financial resources you need to learn to be a researcher and write a dissertation. First thing, if I've helped you, you have no obligation to work with me. At any time and for any reason, you may choose to work with a different advisor or leave altogether. I would hope you'd explain your choice, but you don't need to. Okay, now that you've gotten funding, you need some other things like classes and electives and learning the ropes and some general mentoring, advisoring from all of the opportunities that are going to be presented to you, guidance for projects, recommendation letters, career coaching. Do you want to go into academia? Do you want to go to industry? Do you want to go to the labs? And a thesis advisor who's going to be present and on your side. And so do you need to write papers? If so, you need time and instruction to learn to write a paper. Do you need to give a talk? Well, you should give some practice talks and get feedback. Do you need to float some ideas for projects or directions, or do you want a sense of the publishing landscape to help you decide? Or maybe you just need someone to help you find office space and a computer. These are things I can help with. I'll be your advocate. I'm going to make time for that. And if we at some point decide it's not the best fit for either of us, then I'll help you with your next steps. Our main work will be building toward your dissertation and thesis, keeping an eye on what comes after. I'll help you imagine it. I know some things about some things, and I know some people, and I have broad interests throughout computational science and engineering. It's worth checking whether we have some common interests, and if you're not sure about what you're interested in, I'll try to show you why my interests are interesting. At this point, I have not given you a lot of detail about what I work on, and if a few of you already have specific things that you want to do. Maybe you're here to learn deeply about deep learning. So let me narrow some of my stuff a little bit. Here are a few things that I'm probably not the best fit for in terms of advising. If you're really interested in neural nets and deep learning, or computational mathematical biology, or social science, graphs and networks, classification, natural language processing, high performance computing, software development, robotics, theory of computing, this is all really cool stuff. It's not my area. I'm not averse to ideas from the area, but they're not my expertise. And also there are other people in the department who are experts at this. So I was going to just about end here, and which is just a little over 15 minutes. And I was going to say, if you want to know more about me, then I think the video that we just started is the best representation of my own research headspace right now. And if you want to engage with more technical details, I'm happy to send you papers, but I would never expect a potential student or applicant to have read really any of my work ahead of time. Let's just come talk about it. So if you have questions, send me an email. If you're ready to do this, just send me your CV or short statement of your interests and passions. The deadline for the NSF GRFP is in just about a month. So I would like to hear from you by Friday if you're interested, and otherwise as soon as possible. And so with that, I am going to stop. I see a question. So let me answer the question, which is, what about independent study research opportunities for MS students? I think that's a very interesting question. I would be more open to the idea if the student was also considering a PhD afterwards, and would be open to applying for a fellowship this year, during this year of having your own funding. That if you want to continue, this is a good time to apply for the next step. Yeah. Oh, what is my email? That one I can do. Oh, wow. Good. Sorry. Good question, Charles. I'm seeing questions here. First, I'll put my email in the chat box. And the autocorrect. Oops. Colorado. There we go. Success fail rate. Number of times you've done this approach. This is my first time around. I have advised 5 NSF GRFPs, and I have had 2 that received the fellowship. A couple of those, actually both of those applicants received a number of fellowships. So one of them also got the Department of Energy CSGF, and then the other one got a private fellowship at Stanford. So they did really well, and I feel like I learned a lot about that in the process. I'm making some choices in how I'm going to run my research group, where this is, I think, a good model for me to try right now, and it's really different. You know, I think as an advisor, I'm offering something different, but it requires some effort on your part to say, okay, I've got this time and effort to put together the materials for an application, for one or more applications. But it was a good question. And I hope that answers your question too. It's so strange. I'm looking at the chat box as though I'm going to receive feedback from you. Like you're going to say, oh yeah, cool, thanks. Thanks, cool. Cool stuff that is me. I don't, and I'm a little bit reluctant to, and that's because but I appreciate the question. The slide that was the not me stuff was a lot of buzzwords. Buzzwords are useful for sort of beginning your search, the kinds of things that you're interested in. Oh, these are the things people are saying, and this is how people are talking about these concepts right now. It's sort of the contemporary jargon. I would not want to make a slide like that of my work. I could, but certainly out of context, that I give a lot more context in that video. I think that like if you're thinking computational science, sort of in the space that I was talking about, oh, we're using computers to model physical systems, and then we want to use that modeling for something else. That's sort of the general space. So I'm going to say something else about that. I don't think so. Other than just like, if you watch the video, then it puts all that work into context, into that bigger picture context, which is to me much more valuable than saying, here are the 3 buzzwords that I work on. Okay, why CU Boulder? I was not ready to answer that question because oh, my email, please. Let me do it again. Paul Constantine at colorado.edu. Oh yeah, there it is. Thanks. Let me try to wing this a little bit. Why CU Boulder? I'll tell you that the short and most direct answer is, here we are. After that, I have found that this is that the School of Engineering and this department is very open to collaborative projects, working with other faculty members. And so that is an advantage if you have a fellowship, because you can have co-advisors. Now, co-advisors has advantages and disadvantages. But if I went through the process with someone of saying, of like, hey, let me help you with this fellowship, and the fellowship was awarded, I like I said, no obligation to work with me, but I would hope that we'd have some kind of conversation like, okay, and your interests are better suited over here for you to use that fellowship. And to me, I would much rather have that happen than I get rejected from a grant and then nothing happens. Like in a sense, from my perspective, it's similar in the sense that like, oh, I did some work and then, you know, the resource is going somewhere else. But in this case, if you get a fellowship, I'm going to celebrate whether or not you work with me, right? That's that. Trying to think if there's any other like why CU Boulder things. Oh, the department is really broad also. What that means is, in terms of having a fellowship at CU Boulder, is that there's a lot of space to explore. And if you have a fellowship, one of the great things is that you have that time and space to explore because you don't have TA commitments. And then you also are not tied to, your funding is not tied to a project that may or may not have some kind of deadlines associated with it. So having that freedom to explore is really great. Let me answer one more thing about CU Boulder, and that is, as I look out the window, it's a really nice place. You know, look out the window, and that might be another +1. Honestly, like it is. You know, they voted it the #1 place to live, or somebody did. U.S. News, I think. I think I might question that judgment as far as #1, but I like looking out my window. And let's see. Oh, there's a question about domestic or international. So each fellowship has its eligibility requirements. Now, the big ones, which so sort of the big federal funding ones, are I'm pretty certain that they have certainly the defense ones have a requirement of U.S. citizenship. Now, I'm sort of in the process of gathering other fellowships. And so this time around, if someone chose to do this with me, we would both be looking for fellowships, throw links back and forth. Oh, yeah, that looks good. Oh, yeah, that doesn't look good. So with respect to international students, I know that it would not be possible to apply for sort of the big fellowships like the NSF GRFP, the Department of Energy CSGF, the Department of Defense ND SEG, I believe, and then there's another, the NASA fellowship. Air Force have one? No, I don't think so. Anyway, there's a bunch, and I'm in the process of gathering all of these while I'm simultaneously looking into my camera and gauging interest about who might be interested in doing something like this.
Hey, Paul, this is Kunal.
Hi.
So I was wondering, could you please explain like the task thoroughly that you have been working on, like or a simple project that you have been working on and you are like planning to work on it?
Yeah, sure. So let me I'll just review a little bit of what's in that colloquium talk. So after I talk about computational science, the part that's important to me within my research to date has been working with very complex computational models. And a lot of these complex computational models have a lot of input parameters. And now it can be tricky to say the word model in a computer science context, because some people are thinking of like statistical and machine learning models. Again, this is like that computational science, like these are physical models, modeling how the physical world around us works. But when you put a whole bunch of them together, they become very complex and they have all these input parameters. And now you want to do some kind of a study that says, oh, what happens if I change the shape of the airplane wing? Or what happens if I'm modeling climate and I introduce more CO2 into the system? The more input parameters that you have, the more difficult it is to answer those kinds of questions precisely and quantitatively. And this brings us to kind of an area that's very loosely and coarsely called the curse of dimensionality, which is basically how can you fill an exponentially growing volume with points? And the answer is it has to be an exponentially growing number of points. Okay, that's pretty abstract, but in that space, I work on what you could call dimension reduction methods to take these problems with very complex models and lots of parameters where you want to do some kind of a parameter study. You take this model, you run some tests on it, and then you say, oh, look, I can actually represent this model as a much lower dimensional object, as a relationship between much fewer parameters and whatever that like output quantity is that you're making decisions on, like the global temperature or something like that, or making decisions, whatever it is you care about, the output of the model. And if you can find these types of dimension reduction structures that I work on, which it comes down to a lot of linear algebra, a lot of calculus, a lot of linear algebra, a little bit of approximation theory. I'm definitely more on the math side of things with respect to most of the people, or not most, I'm sorry, with respect to some of the people in the department. Let's see, and then where do I go with that? I have been pretty tied to applications. So I have worked with a lot of different applications across the computational science and engineering spectrum. A lot of aerospace applications. I have a joint appointment, or sorry, not joint appointment. I have a courtesy appointment in Aero. So a lot of environmental applications, a couple material science projects. So I go through a number of examples that I did in the colloquium talk and demonstrate how sort of this parameter reduction perspective can help advance the science and the engineering. Because for me, at the end of the day, I'm really working in three frames all at once. One is the theoretical, where we're doing a lot of math to try to understand, to try to build these parameter reduction perspectives in a very abstract setting, just in the math. Then we want to do computing, where we want to say, okay, here are these things that we developed, and now we want to compute them. And how do we understand the numerical methods? So here's this thing that might be an integral, but all I have is a computer that does zeros and ones. How do I compute an integral using a computer? And that's a whole other thing. And then finally, insight, which is after you've gone through the, oh, I'm assessing my model for this type of structure. Are there things that we can exploit? Is everything reliably computable? Now you ask, what does it all mean? And you go and you talk to your scientist friends or your engineer friends or whoever it was that you were working with and collaborating with, and you can say, look at these really interesting patterns that I've found in your model, or structures or relationships that I've found in your model. And they can say, oh, that gives us insight into this part of the science or that part of the science. That has been my method of operation. I expect that I will continue to do some of that, although I sort of hope that the applications are more driven by students that I work with, as opposed to my own colleagues and collaborators. With that said, I have a sorry, I have a network of colleagues and collaborators. So if someone came in and said, "Oh, I have really a lot of interest in modeling subsurface flow for hydrologic cycles or something like that," I can say, "Oh, okay, well, I have a colleague who does that, and let's talk about how we might put a project together." That kind of thing. Whether that colleague is involved or not, then it would be expanding my interests and doing something I know something about, but taking the opportunity. Because my model, my new model with, or excuse me, my model with this kind of funding idea is to take the opportunity. My job is to help the students, right? My job is to help you. Like, my job is to help you find your thesis and your direction and your idea and your contribution. And I want to be a part of that. What I have come to realize is that the specific technical discussion is an essential and necessary part of that relationship, but it is not the whole thing. That there's a whole lot going on, a whole lot more going on in your lives with respect to what's my career, where should I publish, am I on track, and these are the kind of things that I kind of feel like, that I want to be able to pay a lot more attention to, and then also in terms of my own intellectual engagement, I'm happy to expand. If it's the right fit, as long as it's the right fit, if it's within computational science, if it's an interesting application. Again, I'm just kind of averse to machine learning right now. I'm really into statistical methods. I do a lot with regression. I do a lot with approximation. I do what you might call supervised learning, but no classification. And I kind of think that the deep learning thing, well, I was going to say it's a fad, but it's not really for me. I'll just say it's not for me. Can an applicant apply? I don't quite understand that question. And now, and if Henry might clarify that question while I'm answering Charles, what amount of time can you devote for a fellow in this? And in terms of proposal design for the fellowship, how would you or CS be compensated by the funding for a fellowship? Let me answer the second question, because that is an excellent question. To the best of my knowledge, it is yours. My understanding, and I need to confirm this, is that if you receive a fellowship and choose to work with me, and I am formally your advisor, then the money that you have counts toward my research expenditures. Thank you, Nikita. But I don't get any of it. I mean, I'm not getting any kind of kickbacks. I'm not getting any kind of percentage. And frankly, I don't want it. I mean, a lot of my motivation for this is to say, wow, this bureaucracy is ultra complex with respect to securing funding from external sources for students. And this actually seems like a better way to me, in the sense that like the students have a lot more control, that you're not tied to the deadlines of an externally funded project. You know, you're not tied to the responsibilities of TA or some kind of course assistance. And I don't, man, I just don't want to deal with money. Like I'm happy for you to have it, and I'm happy to advise in all of the things around it. And then for you to have that choice and responsibility on your own, to work with me, to work with somebody else. I think transferring is tricky. I think if you put an application in that says I'm going to go work at this school, then I think it can be tricky to transfer that. I don't know that it's impossible, but I don't know anyone who's done it, and I believe that there is some friction in that case. However, going to an institution and then working with a different person is, I believe, you know, just a matter of sending somebody an email and saying, I'm working with so-and-so now, I believe. And like I said, I'm willing to take on that risk, in the sense of, if you get a fellowship and you go work for somebody else because that's the best fit for you, and that works out for me, I'm going to celebrate like that. I'm happy to do that. Okay. And then Charles had also another question. What amount of time can you devote for a fellow in this? So right now, like, I mean, this is my research project, in the sense that like I have actually let go of most of my commitments so that I can really devote myself to kind of this take on it and to this this approach, because I think that I think this is better, and I'm not. That's not to criticize anyone else who is doing their part. When I say this is better, please let me capture that in. This is better for me in the way that I work, in the way that I think about advising students. And then Charles also asked, in terms of proposal design for the fellowship. Oh, right, compensated, and I talked about the compensation. You're welcome, Charles. Thank you for asking. Have I been an advisor? Can a graduate apply? I have been. I've graduated 2 PhD students. So I used to be at the Colorado School of Mines. I taught in the Applied Math and Stats department there for 4 years. I had, when I moved here, 2 PhD students, a master's student, and a postdoc came with me. At Mines previously, I had co-advised a student who graduated. The 2 PhD, well, everyone who came with me graduated, but 2 PhD students graduated, got jobs at the national labs, and have now become full scientists, like full-time scientists. One at National Renewable Energy Lab in Golden, and the other one at National Institute for Standards and Technologies in NIST. And I'm really happy for them. And can a graduate apply, a master's student? Well, so what we're going to have to do, if you want to talk about it, then what we should do is look at your eligibility for fellowships. I don't know off the top of my head about fellowships for international students, but if someone is interested, then I will start putting my time into. Oh, okay, Henry is a prospective student who will be an applicant for upcoming fall. Oh, yes, Henry. Sorry, I didn't understand your question, and Rashri, thank you for clarifying. Yes, if you are a prospective student now, then you are in an ideal position to apply for a fellowship that would bring you to campus next year. So yes, to the degree that you can send me email, I mean, email and Zoom, like that's how we'll do this. Anything else? We are. Thank you, Jeffrey. We are almost about out of time. Apologize for the sort of like hand wavy technical discussion of my own work, because I really prepared more to be like, hey, I want to tell you guys about how I want to do this PhD thing differently and help some people in the process. So that's kind of my.
Well, I think Charles has another question.
What's your experience with geophysics domains? Oh, that's interesting. Good question. So I did work with a couple geophysics people at Mines. Paul Sava, who he might be department chair by now. And then I was also on one of their hiring committees. We looked a little bit at some like subsurface imaging kinds of problems and subsurface inversion problems. For those particular cases that we worked at, I was looking for examples of my parameter reduction tools. And this particular set of problems didn't seem to respond well. And let me say that slightly more carefully, which is that the type of structure that I look for, which is in particular types of linear subspaces, it didn't seem to be present in their data sets. Wow, we stopped at that point. So I've been on committees. I've been on graduate committees, hiring committees. Had colleagues. I don't think I ever put together a project though, but just sort of a number of kind of interdisciplinary discussions. Oh, what does that data look like? Oh, how do you process it? How do you think about it? What are the problems? That tends to be where I sort of start with a new application, is just to sit down and say, tell me about your problems. Good question. It's very weird to talk to you all and then see myself. I don't usually do the live lectures. I've been doing all asynchronous lectures to my remote lectures. So Zoom, I'm kind of a Zoom newbie. Poor Rajshri. I've been living here for 1.5 years.
So if we don't have any other questions, I think we can call it a wrap.
Cool. Thanks, everybody. Thanks for listening.
Thank you so much, Paul, for doing
yeah,
this.
sure. I'm looking forward to yes, sorry, Henry. Let's chat offline if you want to send me an email. I'm happy to respond and correspond with you. But yeah, thanks again, Rajshri, and thank you for everybody who's coming or who came to this. And I hope to hear from some of you. Thanks.
Thank you.